Hi everyone, this video is on exercise 12 equation 7. So we have the function f of x, which is 2 minus x to the power of 9, and in part A we want to find the first three terms in ascending powers of x using the binomial expansion of f of x. So for now, for year 1 differentiation, if we get something like this in the form of a minus b to the power of to a big power, then probably the best idea is using the binomial expansion and then using that, or even the Pascal's triangle. But you will learn a very nice and easy method in year 2. So if you see questions like this, you can immediately differentiate them. Right, now we need the formula for the binomial expansion, which is of this form. And now in this case, remember that the value of n is equal to 9. So if n is equal to 9, then we can find the first three terms, because we don't need to find every single term. So in this case, the function is 2 minus x to the power of 9, and that's equal to the sum from 0 to the power to n, which is 9 in this case. And then we have 9, and then r, a to the power of 9 minus r, and then b to the power of r. Okay, so we can then find every single term. We can start with r is equal to 0. Again, remember that we want the first three terms in ascending powers of x. So when r is equal to 0, then we are going to have 9, 0 here, and then we have a to the power of 9 minus 0. So also, I forgot to mention, but in this question, let's say a is equal to 2 and then b is equal to minus x. Yeah, because we need them for substitution. Let's write in terms of a and b. So here we have a to the power of 9 minus r, and then b, and that's minus x to the power of r. So in this case, yeah, instead of a, we write 2 to the power of 9 minus 0, and then minus x to the power of 0. Okay, so this is equal to, so 9 choose 0 is just 1, and we simply get 2 to the power of 9, because minus x to the power of 0 is just 1. And 2 to the power of 9 is equal to 512. So that's the first term. Now, the second term is when r is equal to 1. So we have 9 choose 1, and then 2 to the power of 9 minus 1, which is 8. Then the next one is minus x to the power of 1. Okay, so for this one, we first need to find 9 choose 1, and that's equal to 9, and so 9 choose 1 is 9, then times 2 to the power of 8, and then minus x to the power of 1 is just minus x. So for this term, this is equal to minus 2304x. And finally, the last term, because remember we want the first three terms, so we have 9 choose 2, then 2 to the power of 9 minus 2, which is 7, and then minus x to the power of r, so r in this case is 2. Okay, 9 choose 2 is equal to 36, so then times 2 to the power of 7 times minus x squared, which is just x squared. And this term is equal to 4608 x squared. Right, now we have every single term of the first three terms, so we can then write 2 minus x to the power of 9 is equal to 512 minus 2304x plus 4608 x squared. And then this continues, but that's enough. Right, now part B says if x is small, so that x squared and high powers can be ignored, show that f dash x is equal to this. So it's essentially saying that just differentiate what you have got from the previous part. So yeah, we just need to differentiate the function that we got from the previous part. So we can write f dash x is equal to, if we call 2 minus x to the power of 9 f of x, then f dash x is equal to, so 512 differentiates to 0 because that's a constant. Now for this term, minus 2304x differentiates to just minus 2,204. And then for the second term, the power of x is 2, so that comes down as a coefficient 2 times, then 4,608 times x. And this is equal to minus 2,204 plus 9,216x. And that's exactly what we wanted to get. So we wanted to show that this is the derivative. Okay, that's it for this video, and thank you for watching.